Okay, so tonight we're going to be talking about binomial expansion. We have two ways we can do this, but before we get into that, I want you to try and simplify the four expressions on the screen. So pause the video and try and simplify them. Alright, so let's take a look at the first one. We have a plus b to the 0 power, and we know anything to the 0 power just equals 1. So to simplify that, you just write 1. The next one, m plus n to the first power. Anything to the first power is just itself, so we end up with m plus n. Now we have x plus y squared. So when we have a squared, we know that it's multiplied by itself. So we have x plus y times x plus y. And when we distribute this out, we get x squared plus xy plus xy plus y squared. And then we can see we have like terms, so we end up with x squared plus 2xy plus y squared. Okay, so now we're going to look at g plus h cubed. So we know that's g plus h times g plus h times g plus h. So we can kind of use last problem, just change some numbers. We know what g plus h times g plus h is, or g plus h squared. So I'm just going to rewrite this as, I'm going to replace g for my x's and h for my y's. So we have g squared plus 2gh plus h squared. Okay, so now we're going to multiply this by g plus h. So when I do h times h squared, I get h cubed. When I do h times 2gh, you get 2gh squared. And when you do h times g squared, you get g squared h. Now when I multiply my g by h squared, you get g h squared. G times 2gh, you get 2g squared h. And g times g squared is g cubed. Now I'm going to combine like terms. So there's no g cubed, so that just comes down. Plus 2g squared h plus 1g squared h is 3g squared h. Plus 2gh squared plus gh squared is plus 3gh squared, and h cubed just comes down. So we simplified all four problems, but what if I had something like, let's move this down a little bit. What if I had something like x plus y to the 6th? I don't really want to be multiplying x plus y times 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 x plus y to find an answer. So we're going to head over to the little note area on your paper, and we're going to talk about two ways to help us not have to simplify this by brute force. So under this little note area, we're going to write, instead of multiplying a lot of terms, comma, we can instead use Pascal's triangle or combinations. So Pascal's triangle is a way to simplify expressions a little quicker. So what we're going to do is I'm going to show you what it kind of looks like. So first you're going to start out with like a 1 here, and then we're going to put another 1 and 1 here, and then you're going to do 1, 2, 1. So what you do to find this number right here is you add these two together. So our next line would be 1 on each. You always put a 1 on each side, and then 3, 3, because we're adding these two together to find those. And then again we have 1 on each side, and we do 4, 6, 4. We'll do one more. 1, 1, 4 plus 1 is 5, 6 plus 4 is 10, 4 plus 1 is 5, and we have 1. So what do these numbers mean in the middle? What they represent is our coefficients of the terms. So I'll put this in perspective for you in a second. Coefficients. But first, let's see. So we have here represents to the 0 power, or to the power of 0. This represents the first power. Second, third, and fourth. So one thing you're going to notice is when you're simplifying an expression to a power, you're always going to have one more term than the power given. So you can see if we had something to the 0 power, we have 1 term. If we have something to the first power, we have 2 terms. If we have something to the second power, a binomial to the second power, we have 3 terms. If we have a binomial to the third power, 4 terms. Binomial to the 5th power would be 6 terms. And it just keeps going and going and going. So let's put Pascal's triangle in effect. So let's take a look at the first one, x plus y to the 0. From Pascal's triangle, we can see that it's to the 0 power is only going to have 1 term. So whatever the exponent is or whatever, we're always going to put xy first. So we're going to have this equals 1 xy, because that's our coefficient to the 0 power. And what the power means is you're going to start x at whatever the power is and y at 0, and you're just going to keep going. X will go down to 0, y will go up to the power around the parentheses. So just to see it in action, we have 1 x to the 0, y to the 0, which we know comes out to just 1, because it's 1 times 1 times 1. 1 times 1 times 1 is just 1. It'll make more sense as we do more. So let's look at the next one. We have x plus y to the first. So remember, we're going to put 1 x y, excuse me, plus 1 x y. And now we take a look at our exponent. We see it's 1, so x starts at 1, y starts at 0, and then we have x going down to 0, so x goes to 0, y goes to 1, and when we simplify this, we have x, because 1 times x times 1 is just x, plus 1 times y is just y. So we get x plus y. Okay, turn it over, and I'll see you on the back. Okay, so sorry it's a little blurry, but I rewrote the expression. It's x plus y squared. So remember, we're going to start with xy. We're going to do 1. Remember, our coefficient is 1. X to the power that we have, 2. Y starts at 0. Then we are plussing, or adding. I can't speak today. 2. Remember, our coefficient is 2 in Pascal's triangle. X to the first, y to the first. Your exponents will always add to the power we have. So you see 2 plus 0 is 2, 1 plus 1 is 2, and then our last coefficient is 1, x to the 0, y squared. So when we simplify this out, we have 1x squared times 1, which is just x squared, plus 2x to the first times y to the first. So we have plus 2xy. And then we have plus 1 x to the 0, which is 1. 1 times y squared, plus y squared. So that's how we simplify binomials with Pascal's triangle. We're going to do one more, just so you can really see the exponents going down and going up. So we'll go to, it says x plus y cubed. So we have 1 x to our power 3, y starts at 0, plus 3 x squared y to the first, plus 3 x to the first y squared, plus 1 y x to the 0 y to the third. When we simplify this, we get x cubed plus 3 x squared y plus 3 x y squared plus y to the third. So it's a really cool way to simplify binomials. But now when we have something like this one, b cubed minus 4 squared, what we're going to do is we're going to use combinations for this one. So let's go down to combinations, and I'll show you what that's about. So combinations is written as n c r p to the r q n minus r. And these are all multiplied together. So this is going to be in your calculator, so get your graphing calculator out. And I'm going to tell you how to get there, to use combinations. So what you're going to do is you're going to hit Math. You're going to scroll over to PRB, and you're going to select number 3. And it'll come up with NCR on your screen. So let's just practice with this. If we wanted to find 5C3 2 to the 5th 3 squared, what you're going to do is you're going to hit Math, you're going to type in 5 first, then you're going to hit math, PRB, number 3, get the C, then you're going to type in 3, which we get to equal 10. 5C3 is 10. 2 to the 5th is 32, and 3 squared is 9. And we're multiplying that all together, and you get 2,880. So now let's talk about what these these letters are. So n equals your exponent. R equals your exponent going down to 0. So exponent to 0. P equals our first term. And Q equals our second term. So you're probably still a little confused, but I think once you see an example, it'll start to clear everything up. Okay, so we have x plus y to the 4th. Let's rewrite our formula. NCR P to the R, Q to the N minus R. So now let's write over here what N equals. So remember, N is our exponent. So our exponent is 4. R is our exponent, or power down to 0. So we have 4, 3, 2, 1. P is our first term, so that's x, and Q is our y. So now when we're going to do this, you're going to type in your calculator 4C4 times our first term to our exponent. So we start at 4, y to the 0. Remember, they have to add to our power, so we still have our two terms. And if you look here, n minus r, n is 4, and r right now is 4. So 4 minus 4 is 0. Because we have r here. And then underneath that, actually let's do this first. So 4C4 equals 1 times x to the 4th times 1, which is just x to the 4th. So then underneath that, you're going to write 4C3 times x to the 3, y to the 1, and we get that to equal 4 times x to the 3rd times y, which we get is 4x cubed y. Now we have our n value 4, C2 times x squared y squared, and that equals 4C2 is 6 times x squared times y squared, which we get to equal 6x squared y squared. Then we do 4c1, and you get x to the first, y to the third, and we get that to equal 4 times x to the first, which is x, times y cubed, and we get that to equal 4x y cubed. And then let's just move this down a little bit. And then again in your calculator you do 4c0, we have x to the 0 times y to the fourth equals 1. X to the 0 is 1 times y to the fourth is just y to the fourth. So I'm not done here. You have to take everything that we got and put it all together. So we have, this was x to the fourth up here. So we have x to the fourth plus 4x cubed y. That should be a y. Y plus 6x squared y squared plus 4x y cubed plus y to the fourth. So using our combinations, we have expanded the binomial x plus y to the fourth power. Now we'll take a look at our last one, which is right here. I'm going to write it underneath this one. So we have b to the third minus 4 squared. So let's take care of our n values, r, p, and q. And remember our formula is NCR, PR, Q, n minus r. So our n value is what? Our power. So in this case it's 2. R is our power down to 0, so 2, 1, 0. Our first term is b cubed, and our second term is negative 4. So we start out putting 2, then go to math, PRB number 3, get that C in there, 2C2 times our first term, so b cubed squared times negative 4 to the 0 power. So we get that to equal 2c2 is 1 times we have b cubed raised to the second power. What you do with a power raised to a power, you multiply them together. So we have b to the 6th. And then negative 4 to 0 we know is just 1. So we have b to the 6th is 2c1, right? Because we're going down. Power goes down on r every time we do it. So we have 2c1 times b to the b cubed to the first power times negative 4 to the first power, and we end up with 2c1 is 2 times b cubed times negative 4, so we get negative 8b cubed. And last but not least, like I said, we can do combinations with any type of number. As you can see, it could be raised to the 6th, 7th, 8th, 9th power, and we can still be able to expand the binomial with the calculator. So it's a very handy tool to know. So in this one we have 2c0 times b cubed to the 0 times -4 squared, and that equals 1 times 1 times 16, which equals 16, which brings us, remember we're not done, brings us to our answer, b to the 6th minus 8b cubed plus 16. So here's our answer. I hope you enjoyed expanding binomials. See you tomorrow in class for some more practice.